Now, as I mentioned that this is the planet of mass capital M, radius capital R. It is the center, and here is a point A. So, I write here gravitational force experienced by mass M placed at A is how much? Obviously, F is equal to G into capital M into small m by x square. Very clear? This much will be the force experienced, okay, by this mass small m when placed at the point. Okay, what will happen? It will be attracted by the planet. Now what we do? We shift it just against this gravitational force from A to B. Some work will be done. So I write small work done in shifting mass M from shifting the mass M from A to B just against gravitational force. Then it will be dw F into dx G capital M into small m by x square into dx. Then net work done in shifting this mass from the surface of planet to infinity. अब मैं इसको क्या करता हूं, यहां से इन्फिनिटी पे थ्रो कर देता हूं. इन्फिनिटी क्यों? बिकॉज आउटसाइड द ग्रेविटेशनल फील्ड. अब उसका कितना वैल्यू है वो तो नहीं पता, तो बेटर है इन्फिनिटी. देन व्हाट वी शैल हैव, कैपिटल W इंटीग्रेशन ऑफ dw is equal to integration of G capital M into small m by x square dx. और इंटीग्रेशन के लिए वेरिएबल कौन सा है? x इज द वेरिएबल. x का वैल्यू कहां से कहां रेंज करेगा? फ्रॉम r to x is equal to infinity. x is equal to r to x is equal to infinity. That means G capital M into small m integration of x to the power minus 2 dx x is equal to r to x is equal to infinity. Then we can write this is equal to G into capital M into small m minus 1 by x from r to infinity. Look, mind this, we have already discussed its integration. X to the power minus 2 dx का इंटीग्रेशन minus 1 by x होता है. और मुझे लगता है लिमिट ऊपर नीचे हो जाएगा, ये r ऊपर चला जाएगा. सो हाउ मच यू विल बी गेटिंग? आई थिंक इंटीग्रेटेड वैल्यू विल बी G into capital M into small m divided by r is not at all a problem for you. This is the net work done in shifting this. And you know, every work done, right, like all work done, right, all work done is equivalent to some energy. ठीक है? So this work done is equal to काइनेटिक एनर्जी. कितने काइनेटिक एनर्जी से मैं बॉडी को थ्रो करूं, यानी क्या हो जाएगा? G इंटू कैपिटल M इंटू स्मॉल m बाई कैपिटल R इज इक्वल टू हाफ m. आई राइट v स्क्वायर. v इज द एस्केप वेलोसिटी, है ना? यहां से मैं इसको कर देता हूं, यहां लिखता हूं हियर ve is equal to escape velocity. So what is VE? Is it equal to root G into capital M? Root 2Gm by R. I like this equation number 7. I think continuation में मैं जा रहा हूँ, मुझे लगता है इक्वेशन नंबर 7 होगा. अगर कुछ चेंज हुआ तो देख लेना. But as far as I remember, it should be equation number 7. Okay, fine. This is the velocity. This is the escape velocity we are getting. Right. Now we can say by equation 1. You go back to equation 1. Small g is equal to capital Gm by R square, which implies capital Gm by R is equal to G into capital R. From equation number 1, थोड़ा सा mathematical rearrangement, then what we shall get? VE should be equal to root 2 GR. This is the another expression. Equation number 7 and equation number 8 are the two different expressions for escape velocity involving the different physical parameters. जैसे equation number 7 is involving capital G, capital M by R. Here it is only small g and R, like this. So this is all about the derivation. We have got the derivation. Now let us discuss. Here I write some important points. Let us discuss some important points regarding the escape velocity. तो escape velocity के बारे में अब मैं कुछ important points discuss करना चाहता हूँ. ठीक है, क्या क्या important points होगा? Number 1, first you can write from equation 7. It is clear that the escape velocity from the surface of the planet, okay, does not depend upon the mass of the body to be thrown, but it depends upon the mass of the planet. Okay, that is obtained, that we are getting from equation 7. That means equation 7 indicates what? It indicates that the escape velocity from the surface of the planet, okay, from the surface of the planet, from here it will be thrown from the surface of the planet. यहां से थ्रो होगा फ्रॉम द सरफेस ऑफ द प्लैनेट. कितना वेलोसिटी देना होगा? v वेलोसिटी देना होगा. ठीक है, लेकिन क्या बोल रहा है ये v वेलोसिटी जो है ये किस पर डिपेंड कर रहा है? इट इज डिपेंडिंग अपॉन द मास ऑफ द प्लैनेट एंड डज नॉट डिपेंड अपॉन द मास ऑफ द बॉडी टू बी थ्रोन. इट मीन्स whether we are throwing a lighter body or a heavier body, it requires same amount of escape velocity as long as planet is the same. Very clear, planet is the same. Second point is if we here square equation number 8, squaring equation 8, we get v square is equal to twice gr, that is equal to g into twice r. Can we get it? Squaring equation 8, what we are getting? This is what does it indicate? Hence square of the escape velocity from the surface of the planet is the product of the acceleration due to gravity and the diameter of the planet. Acceleration due to gravity and the diameter of the planet. Number 3, it's a very important. Look, moon has no atmosphere. I want to explain why moon does not have any atmosphere. Look, moon, how the atmosphere is created? It is created by the air. Atmosphere is nothing but the envelope of air. Air envelope. Okay. So if the air molecules, gaseous molecules will be there, atmosphere will be created. You know, if I take equation number 8. I refer to equation number 8. According to equation number 8, we can say for moon, the value of r will be smaller than earth and g will also be smaller, much smaller than earth. ठीक है? This is why escape velocity on the surface of the moon is very small. Try to follow me. The escape velocity on the surface of the moon is very small, right? So what happens? Gas molecules are in the random motion. So the velocity of gas molecules can easily cross the escape velocity on the moon. Why? Because the escape velocity on the moon is very small. Note it. Escape velocity on the moon is very small. So gas molecules on the surface of the moon, which are in the random motion, they will easily, their velocity will exceed the escape velocity and they will escape. So no gas molecules can remain, which happens in earth. अर्थ पर इसके वेलोसिटी का वैल्यू काफी ज्यादा होता है, अभी हम कैलकुलेट करके बताते हैं. इसके वेलोसिटी अर्थ पर काफी ज्यादा है, इसलिए गैस मॉलिक्यूल्स उसको कभी क्रॉस नहीं कर पाएगा. सो व्हाट हैपेंस? नो एटमॉस्फेयर ऑफ द मून इज ड्यू टू द लो वैल्यू ऑफ द एस्केप वेलोसिटी ऑन द सरफेस ऑफ द मून, and as a result of which gas molecules velocity will easily cross it, exceed it. This is why moon has no atmosphere. And last point, fourth, for earth, right? Small g is equal to 9.8 meter per second square and capital R is equal to 6370 kilometer. I hope all of you know it. This data is known to everybody for earth. So escape velocity on earth, escape velocity on earth will be how much? V should be it is comes 11.2 kilometer per second. समझे? ये तो स्टैंडर्ड कैलकुलेशन है, मैंने अर्थ के लिए कैलकुलेट किया. इसके वेलोसिटी कितना होता है? 11.2 किलोमीटर पर सेकेंड. वेरी हाई बिकॉज अर्थ इज ए लार्जर प्लैनेट. एक्सेलरेशन ड्यू टू ग्रेविटी ऑन द अर्थ इज ऑल्सो वेरी हाई. सो उनका वैल्यूज को अगर मैं इक्वेशन नंबर 8 में पुट करूं तो मुझे ये वैल्यू मिलेगा. मुझे लगता है दीज आर सम इंपॉर्टेंट पॉइंट्स रिगार्डिंग एस्केप वेलोसिटी. विथ दिस द portion of this escape velocity is also completed. We have defined it, we have found out the expression for it, and finally these are some important points. Alright, in our next class we shall discuss orbital velocity. Okay, thank you.